This is bonding video number 9. By the end of the video, you should be able to identify inter and intramolecular forces. Notice the only difference between the two is the one letter difference, inter and intra. To do this video, you need bonding video worksheet number 9, which can be found on Edline if you have lost your copy, as well as a pencil. And as always, this will be turned in on the following school day. Inter and intramolecular forces are examples of interparticle forces. The particle could be an atom, it could be an ion, it could be a delocalized electron. The force is what's holding these particles together. There's two types of these. They're either going to be inter or intramolecular. Inter, this prefix, we're familiar with this when we talk about interstates. Interstates are roads that travel from one state to the next. Interstate 95 goes from Maine down to Florida. It goes from one state to the next, and it connects them. Intermolecular forces are forces that go from one molecule to the next that hold them close together. These are going to end up being in covalent molecules. Intramolecular forces are forces inside the compound or the molecule. So the A part means it's inside. That holds this compound or this molecule together. These are the bonds that we have already been discussing. Covalent, ionic, and metallic. So an example of this is water. In the water molecule, you have a bond right here, and it is a covalent bond. It is inside the molecule, it holds the molecule together, and therefore it is an intramolecular force. Intra with the A. Ionic bonds, and we've talked about this before, is a little bit different. If you have an ionic bond, you're going to have a lattice structure that's going to be equally bonded in all different directions. So once when we bring out our ionic compound, we see there's an ionic bond here, but there's another one here, another one here, another one here, another one here, and so we can continue to go in all different directions, creating our lattice structure. These are our ionic bonds, and because we have no clear beginning or end, they are all equally bonded, and they are all considered intramolecular forces. Those forces within the molecule or the compound that holds it all together. So what is it that we have that holds one water to the next? That's going to be your inter. Let's talk about that. Intermolecular forces. These are going to be what we find in covalent bonds. If we had a covalent molecule here, from the H to the Cl, that is our covalent bond. This is going to be an intramolecular force because it is inside the molecule. However, we've also talked about how this is a polar bond. It is not a symmetric molecule, so it is a polar covalent molecule. It's going to have a dipole going this direction towards the chlorine because chlorine is more electronegative than the hydrogen. As a result, chlorine is going to be slightly negative, and the hydrogen is going to be slightly positive. The same thing will be true on the next hydrochloric acid, and the next one, and the next one. But since we have a slightly negative and a slightly positive charge, these two are going to attract each other. That is your intermolecular force. Notice the E, because it's from one molecule to the next. So it does connect, but it is not a bond. Since it is not a bond, this force is very weak. It's not as strong as your intramolecular forces, which are bonds and are strong. These are going to be weak because they're not really bonds. However, it does take some amount of energy to separate this from this, just not as much as it would for an ionic compound. Let's try another one similar to this. Water is also a polar molecule. It has a polar bond, it is not symmetric, and so it has a negative side and a positive side. All of your positive sides, which is where the hydrogens are located, are going to attract to the next oxygen on the next molecule. These are going to be your intermolecular forces because they're not actual bonds and they're going from one molecule to the next. So inside we have the bond and it's intra, but from one molecule to the next is inter. Now this force here, because this is a polar molecule called a dipole, and since the next water molecule is also a polar molecule and also has a dipole, these forces that we are talking about are going to be called dipole-dipole forces. A dipole-dipole force is when one polar molecule attracts the next polar molecule. And in doing so, they are going to have a weak attraction for each other that allows them to stick together a little bit, and it does need to be broken to make it melt or to make it boil, but it's just not as strong as your ionic compound is, which are going to have much higher melting and boiling points.